Now that you have a good conceptual overview of how weights are used, let's jump in and create real-world implementation of weights. Let's go back and take a look at a previous lesson where we used touch panel buttons to manage the screen control relays. One of the button events that we created was for a screen preset. All this button did was pulse the screen preset relay using the min2 command, and the screen lowered down to a pre-recorded preset position. Let's change our thinking. Imagine now we want to create our own preset. Pretend there is a whiteboard behind the screen, and we just want to lower the projection screen down halfway so the instructor can still use the whiteboard. We need to modify the code and create our own preset for the projection screen. This is an ideal place to use a weight. All we need to do is edit the code we have already written to delay the action of pulsing a separate relay to stop the screen at a predetermined position. The first thing I'm going to do is to comment out the min2 command. Now, let's clarify the outcome. When the user presses the screen preset button on the touch panel, we want to immediately pulse the screen down relay, which starts the screen moving down. Then, after 6 seconds, we need to pulse the stop relay so that the screen stops at exactly the position we want. Since we have previously defined all the constants we need for each of the relays we need, we can simply insert a block of code within a wait after the screen down relay is pulsed. Let's get right to it. The devchan is dvtp and screen preset. On the push of that button, let's turn on the screen down relay. Here, the devchan is dvrelays and screen down. Now, we get to use our wait keyword. So on the next line, just type the word wait, then a space, then we will add the time parameter. Remember from the explanation a minute ago, we decided the screen should be lowered for 6 seconds. Therefore, the time parameter is 60. Now, open a brace and write the code that will execute when the wait expires. Here, all we need to do is turn off the screen down relay like so. Now, just close the brace for this code block and we are done. Make sure you compile. If you have your own hardware, feel free to load this code and test it. Let me give you an in-depth explanation of what happens here when the screen preset button is pressed. First, we immediately turn on relay 3, the screen down relay. Next, we simply place the code inside the braces below the wait statement into the wait queue. Then, 6 seconds later, the wait expires and we execute the command to turn off the screen down button. What the user sees is that as soon as they press the preset button, the screen starts coming down, then after 6 seconds, the screen stops at the halfway point. Let's take a look at stacked and nested weights. We'll start with the nested weights. We're going to create a sequence of events. Let's say, for example, you have 3 crown amplifiers in a rack. You are using a rack-mounted power strip with a contact closure input for each electrical outlet on the strip. If you wanted to sequence on each of the 3 loads 1 second apart to prevent excessive inrush current, you could simply create a nested wait event. First things first, let's open up our touch panel and add a button on our relays page. Since we've covered this many times now, I'm going to breeze through it. Feel free to pause this tutorial while you complete this step. On the relay pop-up page, I copied a button and renamed it Rack Power. I need to address the button. I'll keep its channel port set to 1, but I'll change its channel code to 501. Make sure the feedback is set to channel. Save and close. Now, let's take a look at how the code might look for such an implementation. First, we are going to be hooking up the rack mount power strip to IOs 1, 2, and 3. In other words, the power for amplifier 1 will be controlled by IO channel 1. Amplifier 2 will be controlled using IO channel 2, and amplifier 3 to IO channel 3. Then, I'll create a constant called rack power button, and the channel we used in the touch panel was 501. If you want to create a constant for IOs 1, 2, and 3, feel free. Since they are simply IO numbers, I'll just scroll down to the bottom of the Define Events section and begin writing the code. We need to build a rack power button event, which will trigger the sequence. Inside the push event handler, we immediately turn on digital IO channel 1 for the first amplifier. Then, insert a wait 10. Remember, wait times are measured in tenths of a second, so 10 tenths equals 1 second. Directly under the wait 10, we open a set of braces, indent, and turn on IO channel 2, which will turn on the second amplifier. I'll repeat this process for the remaining wait, and then turn on IO channel 3. I will then make sure each of the braces that I opened gets closed. I will compile the code to make sure we are all still error-free. Now, after the user presses the rack power button, AMX will automatically power up all 3 of the amplifiers 1 second apart. Let's now look at the exact same example, except this time we'll stack our weights instead of nesting them. I'm going to save some time by copying and pasting this button event. Let's start fresh by deleting everything we see inside the push event handler. In the nesting weights example, we turned on IOs 1, 2, and 3. For this stacking weights example, let's pretend we add 3 more amplifiers to the rack for a total of 6 crown amplifiers. These 3 new amplifiers, which are hooked up to the same rack power strip, will be controlled using IOs 4, 5, and 6. Just like the last example, let's start by immediately turning on amplifier 4 as soon as the button is pressed by adding an on digital IO channel 4 statement. Directly underneath that, add a wait 10 statement. We'll open up a set of braces, and inside of the wait, we'll add the next on statement to turn on amplifier 5. Now, here's the difference. Instead of adding another wait inside the previous one, we simply close the brace. At that point, we add another wait. Except this time, we are going to wait 20. Inside of this wait, we'll add the last on statement for amplifier 6. Because these are stacked on top of each other, they will start counting at the exact same time. Therefore, if we were to make this a wait 10, both amplifiers 5 and 6 would execute at the same time. So the way this whole thing works is, as soon as the rack power button is pressed, on the touch panel, 3 things occur. First, amplifier 4 comes on. Second, a wait of 1 second is started. And third, a wait of 2 seconds is also started. After the first wait expires, amplifier 5 is turned on. Then, after the second wait expires, amplifier 6 is turned on. Once again, make sure you compile your code and ensure you don't have any errors or warnings. Please don't move on until you've cleared any errors. As a side note, if you were to load this code to your master controller and you press the rack power button, can you guess what would happen? Remember, we created 2 button events for the same button on the touch panel. One for the stacked weights example and one for the nested weights. Therefore, when the button is pushed, you should see IOs 1, 2, and 3 cycle on 1 second apart, and you should also see IOs 4, 5, and 6 cycle on 1 second apart also. 2 different approaches to using weights with the exact same result. If you are still having trouble understanding weights, go back and review the last 2 tutorials, Weights Overview and Weights Implementation, before moving on. Next up, you can put what you've learned about weights to the test. It's another exciting exercise.